Hello again, Year 8. Your second lesson on magnetism and waves is contained in this video. You are going to need either a slinky, spring, or a skipping rope, or a piece of string for this lesson. If you can't find string, you can use wool or cotton, but if it's thicker, it's easier to see what you're going to do. Right, your do now is on the start. You have got, of this slide here, you've got 4 questions to answer. You don't need to write out the questions, you can just write out the answers, but I would suggest that you do pause the video while you do that now. Okay, so here are the answers to the questions. This is making sure that we got a hang of last week's lesson so that we're all ready for this week's lesson, which I'm sure we are. Here come your objectives. Now, this week we've got some key vocabulary and we need to know what these words mean, not just generally, but specifically in the context of waves. The 3 key words we're looking out for are amplitude, wavelength and frequency. And you'll need to be able to know and explain the similarities and the differences for transverse and longitudinal waves, 2 different types of waves, and you need to be able to label a wave diagram. Not too tricky. Sure, you're all going to get the hang of this and be fab. Oh, and it was lovely to catch up with some of you at mini school last week. So, first things first. Mechanical waves. These waves need particles to move. They move particles. An example is a wave at a beach here, and they transfer energy using the mechanical energy pathway. Examples are waves in water. This is quite a spectacular one. They're not always as big as this. Sound waves, which allow us to hear. Waves in a spring, hence mentioning a slinky. And seismic waves. Those are the ones involved in earthquakes. And I know a lot of you did really well on the Seneca learning about earthquakes. Quite a lot of scores of 100%, so well done there, Year 8. The other type of waves are called electromagnetic. So that links back to the electromagnets we learnt about last week. And these waves cause vibrations in the electric and magnetic fields. They transfer energy on the radiation pathway. And examples here are light and infrared and X-rays and radio waves and microwaves. We've got a little diagram here showing you what the wave looks like, how it changes as it goes along, and showing you where the different parts fit in. So you've got this bit here is the visible light, which we know will spread out to these colours, which will make a rainbow, very big at the moment. And then we've got X-rays here, we've got radiation there, and then we've got infrared and we've got microwaves. Lots of different types of waves used in real life. You'll have come across quite a few of them. I know a few of you definitely had X-rays. Now, a little bit of revision before we go too far. The 4 energy pathways, 4 at the beginning, to remind us 4, and then it's Mr. He. Mechanical, which is work done, moving a force. Radiation, light or sound or infrared. Heat via conduction, that requires contact. Think about a electric hob where you put a saucepan on, or you have a gas hob you put a saucepan on, and either the flame touches the saucepan or the hob touches the saucepan, and the heat is transferred via conduction because they are in contact. And electrical work done, that is current. Here comes your diagram next. Now, you need to copy this carefully. Before you do that, I'm just going to give you a few little bits of information. Now, you'll notice this is a regular shape. So you've got a loop up here, you've got a loop down there. These loops have the same height and depth. The next loop is the same again, so this is a really regular shape. So if you're going to sketch it, you need to be careful. I would draw a straight line here and a straight line there. Then use your ruler to make sure your peaks are at the same height across when you go across, and your depth should be the same as the peak, but in the opposite direction from the x-axis. And this actually shows you the vocabulary you need to learn. So the amplitude is this line here, a wavelength going from here to here. Okay, so you've got little lines to show where that goes. This is a really important diagram for you to learn. Make sure you copy it carefully. If it's scrappy, it's not going to help you. If it's a good job, which I know you're capable of, it will really help you. Here comes the vocabulary next. Now, amplitude is measured from the middle of a wave, the midline, which was like the x-axis going across, up to the top, which is called a crest, or from the middle to the bottom, which is called a trough. You don't need to know those, you probably know those words anyway. But the distance is the same. It doesn't matter whether you're going up or you're going down. From the middle line to the top or the middle line to the bottom will be the same. That is the amplitude. Now, the mistake that some people make is having the amplitude from the top bit, the crest, all the way down to the trough. They do the whole height. It's not, it's just half. So that's the bit you need to be careful of there. Wavelength is the distance from one point in the wave to the next identical point. This is why it's really important that you're careful drawing these out neatly so the shape is regular and repeats. And frequency, you actually need the waves to be moving to get that, because that's how many whole waves pass a point in 1 second. And you'll hear about frequencies when people talk about radios, and they say, oh, what's a frequency for the signal? And different frequencies are used for different radio stations, so they don't mix all the music and the chat up together. So you will need to copy out that vocabulary. You can put it in your own words if you want to, but really I would probably suggest you learn the definitions there, because you do need to know those. And this comes up all the way to GCSE, so we might as well get really good at it now. There's information video here about transverse and longitudinal waves, how they are the same, how they are different. You're going to want to make some notes, and if you've got a skipping rope or string or a slinky at home, you can have a go at making them. So you might want to watch it a couple of times. I will post this link separately in Teams and Go for Schools, so you can get to it without having to go through the whole PowerPoint each time. Now, as a vocabulary checkup here, I've done 2 diagrams. I've done some little arrows in them, different colours, but the labels are missing. I need you to copy the diagram and label the parts that are marked. Now, this one is electromagnetic radiation, transverse, nice and easy, and this is sound waves. If you're not sure of those labels, you'll need to go back to check the earlier diagram. You might need to rewatch the video as well. Now, your task for this week is to make a poster about waves. It must demonstrate, that means not just have the words on, but have explanations or a diagram to show it quite clearly. Amplitude, wavelength, frequency, transverse and longitudinal. So I'm going to guess you're going to have at least 2 diagrams on there. Remember, it's not a it's only a picture until it's labelled. When it's labelled, then it becomes a diagram. You can be as creative as you like. Maybe you might want to reuse your string by gluing it on carefully. I would suggest if you're going to do that, you draw it out first rather than getting glue and string on the paper and getting a bit of a sticky mess. It's very easily done. Obviously, you'll need to take a photograph of that, or you can get creative. You could do it with paint. If you're on a laptop, use paint to do a drawing, and this is the bit that you need to submit either in Teams or via email. I will be giving our points for the best posters, and I may even ask you to keep the original and bring it in September so that I can brighten up whichever room I'm teaching in. So that should be quite clear. I'm not in mini school this week, I'm back at home, so that means it's very easy to get hold of me either on Teams or on email if you've got any questions. Seneca, you will get your last assignment this week, which would be Seneca at Home number 9. Surprisingly named there, I know. Once you have done that, if you have done all 9 of the Seneca assignments I have set, you will have revised all of Key Stage 3 Science, ready for moving in to Year 9 next year. If you have missed an assignment in the past, you can still access it. If you have any problems finding that, let me know and I'll send you a screenshot of how to do it. It's really easy. Let me know as well if you go back and complete any of the earlier assignments you missed at the time, because when you tell me and I double check it, you can get yourself an R2. So there's a chance for loads and loads of R points. Of course, it's always R2 for when you submit your work for the week and another R2 for that week's Seneca assignment. So that's at least 2 R2s available to everybody this week. R3s if you do really well. For example, getting 100% on everything on Seneca. And I had to give quite a few R3s last week, so well done, Year 8. Anyway, I'm going to stop talking now so you can get on and work. Have a great week. You know where to find me if you need me, and take care, everybody. Stay safe.